For this lesson, we're going to be looking at the applications of Pascal's triangle. So we will be using the information from lesson 1.5a and applying it to some real-world situations. The first situation that we'll often use Pascal's triangle for are checkerboard paths. So we want to determine how many paths from the starting position, which is this round checker right up at the top, to the bottom of the board. Remember, when playing checkers, we can only move diagonally in a downwards motion, one square at a time. So what we're going to do is we're going to go through and look at all of our possible pathways. So we're starting right here. So there's only one way to get to that spot because that is our starting spot. Now we can only move diagonally in a downward motion. So from here, I could go this way or this way. There's only one way to get here and one way to get here. Already you can start to see Pascal's triangle forming. Now from these two spots, we can continue moving diagonally and downwards. So we could move over here or over here. We could move over here or over here. Now for the end ones, there's only one way to get there. I go here and I just keep going that way. There's no other way for me to get to that spot. Same with this way over here. No other way for me to get to that spot. However, with this one in the middle, I could go that way, one option, or I could go that way, a second option. So there's two. This is where we really start to see Pascal's triangle form. You notice that I am just adding the two numbers above that are touching the box below. Let's make the third row. So from here, I could go over here, I could go here, I could go here, here, or here. Now at the far left one, there's only one way to get there, and I'm continuing to build Pascal's triangle. The next one, 1 plus 2 is 3, so there would be 3 ways to get here. Next one, 1 plus 2 is 3, and then 1. I'm just going to continue in this same way to the bottom of the board. So at the far left, I could go here or here. From this 3, I have 2 options. From the second 3, I have 2 options. Now from this 1 at the far right, you'll notice I can only move downwards diagonally to the left. I can't go to the right because I've run out of board. And that's okay. We'll just draw arrows and we'll draw numbers for the spaces we have available. So we'll start on the left. It's only touching a 1, so there's only one way to get there. Next one, 1 and 3, so 4 ways. 3 and 3, 6 ways. 3 and 1, 4 ways. And we're just going to continue like this. I like to draw the arrows, helps me visualize it, but you don't have to. So we have 5, 4 plus 6 is 10, 4 plus 6 is 10. This one here is only touching a 4, so we continue with the 4. Then next row, this one's only touching a 5. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 4 is 14. Finally, at the bottom, 5 plus 15 is 20. 15 plus 20 is 35. 20 plus 14 is 34. And this last one is only touching 14, so it's 14. So to find our total, there's 20 ways to get to the bottom here, 35 ways to get to the bottom here, 34 ways to get to the bottom here, and 14 ways to get to the bottom here. So in total, to get to the bottom, we have 20 plus 35 plus 34 plus 14 ways for a grand total of 103 ways to get to the bottom of the board. Now we can also up the difficulty of these kinds of questions. Sometimes, maybe there's some spots that we can't go. So for example 2, we want to determine how many paths from the starting position, which is the round checker again, to the bottom of the board. The checker can go through any of the squares except the ones with the X's. We cannot go to those spots. Again, our checker can only move diagonally only in a downwards motion, one square at a time. So let's start in the same way we did before. There's only one way to get to our starting spot. We just put our checker there. So only one way to do that. Then from here, I can move in a downward diagonal motion. So I can go this way or this way. And I'm just doing the exact same thing I did last time. And 1 plus 1 is 2, and that one's only touching a 1. Okay, so I just keep going. 1 plus 2 is 3. And now I've hit one of those x squares. We cannot move to this x square, so I'm just going to skip it. I'm just not going to touch it, and I'm just going to move on with the square on the far right. So I could still move over here, and I have a 1. So we'll just leave that square with the x. Don't worry about it. Now let's move on to the next row. I could move here, only touching a 1. Could move here. 1 plus 3 is 4. I could move here. It's only touching a 3. I can't put an arrow here. And that's because I can't have a checker there, right? My checker can never go through that spot. So it's only touching the 3. I just put a 3. Similarly over here, the spot's only touching a 1. So I just put a 1. Now I continue with the next row. I have another x, so I can't do anything there. That's okay. We'll just continue on. So over here, 4 plus 3 is 7. 3 plus 1 is 4. And it's only touching a 1. Now, this one here, I can't get to that spot. There's no way for me to get there, and that's fine. I'm just not going to fill it in because there's no way for me to get to that spot. So I just continue with everything else. Over here is just touching a 7. 7 plus 4 is 11. 4 plus 1 is 5. Final row, only touching 7. 7 plus 11 is 18. 11 plus 5 is 16. And that one's only touching a 5. So, again, to find my total number of ways to get to the bottom, the total is equal to 7 plus 18 plus 16 plus 5 for a grand total of 46. And it makes sense that this is a little bit less because we've added on some restrictions there and we can't use all of the spaces. Okay, so the next application that we commonly use are street routes or paths. So for the following map, a person travels south and or east to save traveling time. How many different routes are there from First Street and 7th and 7th Avenue to 6th Street and 11th Avenue? So for this map, we can only travel in two directions. We can go south, which is down, and east, which is to the right. Now we want to determine how many different routes there are. We're looking to start at 1st Street and 7th Avenue. That's our starting point. And we're looking to end down here at 6th Street and 11th Avenue. Now, if you have this page printed out, I would highly encourage you to turn your page on a bit of an angle. That way you can see this like a Pascal's triangle. Really helps. So we're going to start here. There's only one way to get to my starting point. Now I have a couple of directions I could go from here. From this spot, I could go down over here, or I could go this way. This means there's one way to get here and one way to get here. Again, you can start to see Pascal's triangle forming. From this spot, I could go down or to the side. From here, I could go down or to the side. So one way to get here, one way to get here, and 1 plus 1 is 2. I'm just going to continue in the same way. So I could go down or to the side, down or to the side, down or to the side. So 1 plus 2 is 3, 2 plus 1 is 3, and 1. I'm just going to continue. So this one's only touching a 1. This corner's touching 3 and 1, so 4. This corner's touching 3 and 3, so 6. This one's touching 3 and 1, so 4. And this one's only touching a 1. Next one, 1 and 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And a 1. Then 5 plus 10, 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. Then 15 plus 20 is 35. 15 plus 20, 35. 15 plus 6 is 21. And we're almost done. 35 plus 35 is 70. 35 plus 21 is 56. And our final stop, 70 plus 56 is 126. So, therefore, there are 126 different routes that they can take. Let's try another one that gets a little bit more complex. We don't always have just standard rectangles like this. Sometimes our shape is a little different. So here we're going to do the same thing. The only thing is we need to be a little bit more cautious of which directions we can go. So we'll start at A and we want to go to B. We can only move right and down, very similar to what we were doing before. So we want to start here and end here. Okay, so there's only one way for us to get to our starting point. From our starting point, we could go down or to the right. So we can go down or to the right. So if I follow those lines, this is only touching the number 1. This is only touching the number 1. From here, we can go down or to the right, or we could go down and to the right, just like that. So here's only touching one line, so 1, that's only touching one line. This one's only touching one line, only touching one line. So these ones are a little bit harder to see, definitely require some practice, but just try to follow along the best you can. So then we can go down or to the right, down or to the right, down or to the right, or down. So let's figure out how many ways we can get to the ends of these routes. This is only touching a 1. 1 plus 1 is 2. 1 plus 1 is 2. This one's only touching a 1. And this one down here, we need to wait a second because I can also go this way. So I need to find the other number there. Okay, now let's continue again. From this point, I could go right and then down. Here, I could go down and right. And here I could go down. So 1 plus 2 is 3. 3 plus 2 is 5. 2 plus 1 is 3. And 3 plus 1 is 4. Just like that. Now we continue on again. So we can go here or here or here. 4 plus 5 is 9. Here is 4. Then we could go down or to the right. 9 plus 4 is 13. Go down or down. So we'll have 9. And 13 plus 9 is 22. So these ones are definitely more challenging, but the more you practice them, the better you get at them. So there are 22 roots. There we go. All right, one more quick application of this stuff. The last application are paths through letters. So very, very similar to what we were doing before. If you look here, we have all of the letters to the word agenda. Now we can spell this word by going diagonally downwards, left or right. We can't go straight down. We go diagonally left or right, and we want to figure out how many different paths would spell this word. So let's start with agenda. So we can go down left or right. One way to get to the A, because it's our starting point. From here, I could go downward, left, or right. So one way to get here, one way to get here. From there, I could go diagonally to the E, diagonally to the middle E, or over here. So one way to get here, 1 plus 1 is 2 to get to the middle one, 1 on the end. Again, to get to the ends, we would have 1 plus 2 is 3, 1 plus 2 is 3. Then, to get to the D in the middle, 3 plus 3 is 6. And to these, they're only touching 6, so 6 and 6. So, because we could either end at the first A or the second A, we multiply. So our total would be 6 plus 6, which is 12. Now we continue this again. This one, it should just say Horton, but we actually put an L at the top, so we'll just spell it with an L at the beginning. So we have a 1 here. So we continue with our ones. 1 plus 1 is 2. That 2 is the only thing touching the R's. Then this is only 2. 2 plus 2 is 4. And the 2. Our 2's extend to the ends. 2 plus 4 is 6. 2 plus 4 is 6. Then here, 6 plus 2 is 8. 6 plus 6 is 12. 6 plus 2 is 8. So our total, 8 plus 12 plus 8, is 28. And our final option for management, 1, then each of these gets a 1. 1 plus 1 is 2, and a 1 on the end. 1 plus 2 is 3. 2 plus 1 is 3. 3 plus 3 is 6. These E's are only touching the 6. 6 plus 6 is 12. Then these E's are only touching the 12. 12 plus 12 is 24, and those are only touching the 12. Then we have 12. 12 plus 24 is 36. 24 plus 12 is 36, and 12. So our total is 12 plus 36 plus 36 plus 12, which is 96 different pathways.